And Paul, our technical lead, will be talking to you about, or give a demonstration of how we're going to develop and implement our designs. The role of the UX team here at TRIAD is to design mobility experiences that are trustworthy, safe, and enjoyable to use. We've worked with Lexus and ED² to apply UX thinking and safety critical considerations to their new concept vehicle, which you can see here. One of the most safety critical functions in autonomous vehicles is figuring out how do we pass control from the driver to the vehicle. What you see in this design iteration is an example of how this control, how this flow can work. So what you see here is the flow being staggered so that once a user confirms that they would like to enter autonomous mode, control is passed over in a staggered fashion which goes from. By implementing a more effective design and development process, one that is tailored to the automotive space, we can iterate and improve features fast. As a result, we can produce quantifiably safer solutions. Alongside our new design process, the software teams are building new tools like Arene to facilitate better development. All the designs you'll see here today on the screen and also in the simulation stage are all built using our Arene platform. And with that, let me introduce Paul, our technical lead, to tell you a bit more about how we take designs through to implementation.
On the engineering side, we've been working very closely with the UX team to design many of these tools so that we can enable a much more quick iterative cycle where user feedback and user research is incorporated to each design step. So today we're going to be showing a first prototype of one of these tools, the Arene Lab, which you see on the screen here. The Arene Lab is a desktop application targeted at designing and editing vehicle user interfaces. Today we're going to be editing the design for the Lexus LF30 interface. On this screen, you can see that there are many possible vehicle interactions which we can design for. Today we'll be editing the design for a vehicle human control handoff all the way on the left. In this case, following some user feedback, we're going to be changing the confirm button to be a little more visible. Once these changes have been made, we can now test these changes on real or prototype vehicle hardware using the Arene bench, which is on the table to my left. So the Arene bench is modular. It's composed of different hardware components. In this current setup, we have some real ECU hardware, coupled with some prototype hardware as well. The idea here is that because it's modular, we can change the configuration depending on what we want to test. So we can add lights, sound, haptics, depending on what user interaction we want to test. And behind me, we've actually deployed the latest changes from the desktop application, Arene Lab, directly to the ECU in the Arene bench. You'll note that there's a very tight integration between design and deployment here, the developer PC, and we can see the changes appearing here in real time. So Arene Lab and Arene Bench are just two of the tools that we're currently working on in TRIAD. In the next station, you'll see another platform that we've been working on, the UX simulation platform. So that will be shown to you by Matthew Dole and Sabrina Lee. And thank you very much for your time. And if you just head over there, then you can see the next station.
Hi, my name is Matt Doyle, and I am the head of user experience simulation here at TRIAD.
As we mentioned earlier, we use a data-driven design approach with Arene platform. Designs are tested and iteratively improved at every stage. Here at this stage, we test our design in the simulator, where we can safely and quickly measure the details of user experience. There are many virtual scenarios that we can create that will allow interactions and driving with the UI that we designed and deployed from the previous stage.
So, as Sabrina is saying, using the Arene platform, we can take the designs from a developer workstation and we can bring them into a simulator. And after a lot of testing, we can bring it into a vehicle. using the same underlying code each step of the way to ensure critical safety aspects. So today we're very excited to give a live demonstration of this simulator. But before we turn it on, I would like to invite everybody here into the simulation room to take a closer look, and we can explain how we use this in our tests. So please join me. This simulator is designed to complement a virtual vehicle cabin and virtual environments that are as close as possible to the real world. This allows users to experience a realistic scenario, and we can measure their response in a safer and more efficient way than ever before. So this is modular and it's configurable, which means that we can configure it to be any kind of vehicle. This can be a Toyota Prius, a Lexus SUV, or even a concept vehicle like the Lexus LF30, which was just announced yesterday. So Lexus revealed the LF30 to the world only yesterday, and yet today we can sit in it and test that experience ourselves.
Okay, we're starting the next stage. So this way. Thank you very much. We improved this part to be more noticeable for users and just implemented in the simulator. So with various user research methodologies such as eye tracking, hand tracking, and response time as safety critical interactions. And look at the camera relay of the participant encounters. So through this monitor, we can see what the car sees, what the user sees, and some biometric data from inside. Safety first, of course, there is an emergency button. Okay, the camera relay, we need to set up a little bit again. Yeah, okay, let me introduce here some data from here.
So what we're looking at here and what we're doing is testing a scenario. But while we're looking at this scenario, there's some important things to point out. We have very innovative and world-class technologies running under the hood. It's important to point out that we're developing hardware in a loop. Having hardware in a loop means that everything we're testing on the Arene platform is relevant to the exact same command signals and sensor arrays in real vehicles. Using the Arene platform, we plan to emulate the hardware found in many different cars, since obviously not every car is built the same way. So this simple test looks at a prompt for handing control over to a vehicle. We saw eye tracking and hand tracking to help us understand response times. And we can review this data in much more detail afterwards and share this feedback with designers for the next iterations.
Okay, now we are at the final destination. So we can see the user is enjoying the view around, and her hands are off from the steering wheel and feeling relaxed. So as you saw, with the Arene platform, we can quickly test the scenario many times. Each time, we can focus on different safety critical interactions.